his laptop just after I did. He got a new one.
Alright, so I'm going to be talking about the Linux Logical Volume Management suite of tools. I designed it as a lightning talk. I haven't timed it, but the goal is 10 minutes or less. I know I'm going to go long. You ask any of the students that I teach at OCC, and they will tell you I always go long. I'm the very last one to leave the building every Wednesday night. So, LVM is the shortened version for Logical Volume Management. It is a Linux-specific implementation, but the idea of volume management is common across a wide variety of operating systems. Dynamic disks on Windows, HP UX, AX, they all have their own type of logical volume management. I don't know if it's still the case, but for Unix boxes you can pay for instance, like Veritas Volume Manager, and you pay lots of money for Veritas Volume Manager, and this is Linux's version. It's free. If you wanted to email me, that's my home email, it's the one we'll list on. But alright, I'll jump in. So, overview. Background on LVM. Why would you use LVM? The structure of LVM, example commands for typical operations, things to watch out for, Q&A. And depending on how time goes, I might do a demo, might not, we'll see. But this is not designed to be super in-depth, just super quick. Hit the highlights. So the background. Hard disks on modern systems are viewed by the operating system as a single contiguous series of logical blocks, or sectors, starting at 0. Sectors are either 512 bytes or 4K on the newer drives typically, but as far as addressing goes, you start at 0 and you just kind of seek into the device wherever you need to be. The file systems typically expect to be on a single contiguous series of logical blocks, because that's what the hard drives have always been designed to represent. Traditionally, partitions have been used to carve up hard disks into smaller, isolated series of logical blocks. So you have 0 to whatever the maximum number on your hard drive is, and you want smaller slices. Well, that's the old partitioning table, fdisk. Of course, being the tool that we all know to do that. But there are problems with partitioning. And that brings us to LVM. Partitions do have a lot of drawbacks. They must be contiguous on the hard disk. They're difficult to change after creation. If you resize them smaller, you leave gaps because the next partition is starting wherever it started. And if you are resizing larger, it requires something I didn't actually finish. Resizing larger requires having that extra space contiguous on the end of the partition that you are growing, or then you have to jump through a bunch of hoops. You've got to move partitions or shrink the starting point and relocate the data.
I thought that was a joke. Resizing larger requires, and then you lost it because you didn't resize.
No, that was just me getting sidetracked and having the attention span of a gnat.
That was him going through.
The other part is you can't span multiple hard disks with partitions, so you're stuck with whatever that hard drive has is what that hard drive has. And this, I don't know if this is a generic problem, but it certainly seems to persist across certainly many different versions and many operating systems. If any partition on a given partition table is in use, you can't rescan for updated partitions live. This may have been fixed in pretty recent versions of the kernel, but it's been a very persistent problem for a very long time. Like for instance in Red Hat 5, which as Alan said is most of our environment at Secure 24, we continuously have requests to add space, grow volumes, things like that. And you cannot, and the expectation of course is that the downtime will be minimal or non-existent. And if you do have to have downtime, of course, then one of us has to be up at midnight, 1 in the morning, some ridiculous time to do it. Because these are all critical applications and you can't take an outage during the day. So being able to rescan for changes live is of critical importance to our sleep schedule and overall quality of life. So, maybe if you're on a desktop, it's not a big deal, but it can be a very big one. And if you can't rescan to see updated partition tables, then there's certain things you can do so that works, but it's not consistent. You have to be very careful. So LVM was designed to address these challenges and more. Structure of LVM. Fundamentally, it's an abstraction layer for storage devices. LVM breaks down storage into 3 major building blocks: physical volumes, abbreviated PVs, volume groups, abbreviated VGs, and logical volumes, LVs. Physical volumes essentially map one-to-one to your actual storage block devices. So be it a partition table, an entire drive, an encrypted loopback device, anything that you can address as a block device, you turn that entire block device into a PV. You can't carve it up any smaller. If you need to carve it up smaller, then you're back to using partitions or some other way of dividing it. Volume groups are collections of PVs. And you can have multiple volume groups on a given system, but a single physical volume can only belong to one volume group because that's sort of the smallest chunk of space you're looking at. Volume group looks like a big pool of storage you can allocate from. It's just sort of this amorphous amount of free space that is going to be the total of all of your PVs minus a little itsy bit for the overhead of the metadata that LVM uses to keep track of its structures. And because it is made from PVs, a VG can span multiple partitions, devices, or even different types of storage. Now, I'm not going to say you should do this, but you could have a single volume group that consisted of like RAID 10 storage, RAID 5 storage, SSD, just a single hard drive hanging off a SCSI bus somewhere with no RAID or anything. It's very flexible. It doesn't care. Block device, it passes. Logical volumes are really sort of in your head what you can map to more of the traditional partition concept. You carve up a volume group's storage into logical volumes, and when you create the volume or the logical volume, it shows up as another block device, and therefore it shows up as contiguous sectors and storage. It may not be behind the scenes. LVM uses another technology I talk about in a couple of slides under the hood, but it makes that storage, wherever it lives that it's using, look to be contiguous, and then the Linux kernel will actually remap it under the hood to make it go wherever it needs to go. The upside of that is it can be easily resized. As long as you have the storage anywhere, you can grow it, you can shrink it. You don't have to worry about gaps, because if you end up with a small gap, since it doesn't have to be contiguous and it doesn't care about where it lives, you can just, say I'm going to use that little, 100 meg chunk that you've got freed up in between two other LVs. So, some example commands. If you had block devices, dev SDB, SDC, and SDD, and you wanted to set them up for a volume group, you would first have to PV create.
Good evening. If I may have your attention, the time is now 8:30 and the library will be closing at 9 this evening. Please be advised that the library's internet computers will shut down approximately 10 minutes before closing. Thank you.
Well, that's
Not a problem, we'll be through this.
That's a lot better than the internet being down.
Yeah.
You said last time.
They took the whole internet down.
That was a little disappointing. But it did get people out.
Freaked out.
Now I'm going to stop here and make one point. So you'll notice on these block devices I'm listing here, I'm listing the device itself, not a 1, 2, 3, or 4 for the partition number. A lot of times in a lot of examples you will see the partition number there, and in fact on your boot drive you still have to have partitions. So you'll have partition numbers there, but if you're dealing with just storage that's going to be dedicated solely to LVM, you want to think very carefully. Do you want to create a partition table? And to my point earlier about it being tough to sometimes re-scan partition tables, especially if in a SAN environment where you have this huge amount of storage that you can just kind of draw from to make your SAN mounts, if you've got a partition table, you can't grow the storage under the hood and rescan the partition table to see the bigger storage without a reboot. So right there, you're using a partition table and you're limiting your options for maintenance windows. So my personal best practice is if it's going to not be a boot drive, you just use the whole block device. You just say the whole thing. Now the downside, of course, is if you're working in a mixed world where you've got other operating systems, HPUX, AIX, Windows, and maybe the Unixes are a bad example because I don't know what they would do if they saw an MS-DOS style partition table, but if you had a Windows guy who bumped across this SAN mount and didn't see a partition table, they probably would assume it's an uninitialized storage, because Windows obviously isn't going to tell you about LVM. So you do incur the risk of it maybe being less obvious to somebody that doesn't know what's going on with your data in your volumes about what that storage is. But you gain the advantage of having it be more flexible. So, win some, lose some. But the PV create command, what that does is it just puts a little label on each of those devices, a certain number of sectors into the beginning of the device. You can also tell it to basically do 2 metadata areas where it would also put some at the very end. And it just basically adds a signature that says this is available for LVM, and that's it. It's not like a long format process, it's very quick. Then once you have them sort of tagged, then you can create a volume group. So here, creating volume group 0, VG0, a new volume group out of SDB and SDC would be that command, VG create, VG0, and then you give it the components you've already tagged with PV create to go into that volume group. I didn't list it here, but after you do VG create, VG0, you could run the VG display command, and it would show you that you have a volume group. It's not going to actually list the details of the underlying components in that view. There's different ways to see, how the fundamentals are looking as far as what block devices in use. But it will show you that you have the free space that is roughly the total of those two block devices available. So then, now that you have all this free space in this amorphous storage pool, you can create data, a new logical volume on VG0. And here's the command lv create -n, that's the name of the logical volume, -L. Now there's two ways you can specify sizes. I prefer capital L because it lets you specify things in terms that humans think, 5 Gs, so 5 gigabytes. And then the very final option is VG0, that's the name of the volume group you want to create the logical volume data in. And then at that point you have a block device. For convenience, LVM is very, very nice. And this may be different on different distributions. I think it's the same on all the major distributions. If not, someone feel free to tell me. But under your dev directory, as soon as you have any activated logical volume, you get this sort of dynamic path where you've got volume group name / and then a different entry for every logical volume in that volume group. And you've got a new volume group entry. The trick here is a little gotcha. If you create the volume group, and then you don't create a logical volume, this is not here. You cannot tab complete dev VG0 because that whole structure doesn't get instantiated until there's at least one active logical volume. So you still sometimes need to reference the volume group by name, which you can always do. And this is just a convenient shortcut because I like to tab complete. So more example commands. So now you've got this VG0 and you want to add the third PV to it because you created it sometime after the first two or you forgot about it. VG extend, VG0 dev SDD. That just updates the metadata to say now you have this new SDD. And one really nice thing about LVM is when you do the PV create, it generates a UUID that it tags every PV with. So a unique identifier that's theoretically never going to be duplicated. And when you add them into the volume group, it keeps a list in the metadata of all these UUIDs. So if you play musical chairs with your block devices, and SDD becomes SDF, and SDC becomes SDB, and SDB becomes SDE, it can still reassemble them, because all it does is look for the signatures and pull out the UUIDs from those volumes. So it takes a lot of that old headache and heartache about, gee, I've added a new hard drive, and my boot order is shifted, or I've added a new, if your plan stands, possibly, the Lund presentation order is shifted, things like that. It makes all of that completely transparent to you. It's really nice. So anyway, once you've added the PVs, you don't have to think about what the block device is anymore unless you need to do something with that particular block device. Then to expand the existing LV data volume on VG0 by 10 gigs, you can do LV resize -L, and you can use the plus notation here. It's very important. If you don't specify the plus, it will make it exactly 10. It won't add 10. So you have to be careful if you've already got a file system, and it's like, let's say the file system is 10, and you want to do +5, and you forget the plus, and you say 5G, it will lob off the last 5 gigs of that file system. So these commands are not to be used without double checking and knowing what you are doing. They're very powerful, and it's like most things in Unix, they give you the loaded shotgun. So use it smartly, wisely. Yeah.
So when you resize like that, I assume all the data would be there that would just be lost. You just clip it off, and
it would clip it off. And I mean, the data would still be on the drive.
Yeah.
And you might be able to resurrect it. I've never tried, but it wouldn't be as simple as just saying +5 again, because it might jump the data, to some other free segment. Alan.
I can't remember the name, but there's a tool that'll help you rebuild from stuff like that, because every time you make a change
Is this something
like
you've
this,
done before?
From experience.
every time you make a change like that, it stores your LV config in a text file, and it's the lvm.d or something like that.
Yeah, like a backup of the metadata.
And it makes a backup of your metadata, and you can just take that and restore it. And so you can, assuming you haven't lopped off the 5 gigs, went about your day, and overwritten that 5 gigs with something else. But if you went, oh crap, I forgot the plus, you can go back to the config file and pull it back. I don't remember what it is off the top of my head, but
Yeah.
all is not lost.
Yeah, and we're not going to get into that level of detail with the metadata backups and things. Maybe if you ever convince me to talk for an hour and a half on LVM, we'll look at that. But I have thankfully never needed to do that. That's my fingers. But the other thing, though, is to Alan's point, if you did do that, the data will not be touched as long as you don't run more LVM commands, because that data is going to be unallocated, untouched, unprocessed. It's not like a file system where you delete a file and there's things still going on all the time. So it's not a great situation, but at least it's predictable as far as long as you don't continue to modify your volume groups, you're not going to continue to have changes on the unallocated space.
I'm curious, what happens on PV move /div/SDD? You're obviously moving the data off that hard drive. What happens if you get a sector error or a hard error on that particular drive? Do you lose all the data, or what happens?
It's a good question. I've never bumped into that. I suspect it would essentially work the same as if you're copying a file. At some point it would throw an IO error. I don't know if it would abort or keep going. I don't know. I've even at home, I've run rated configurations for so long, I haven't bumped into sector errors.
That gets abstracted away by the hardware layer these days.
Yeah. I would suspect it's probably going to abort the PV move and roll back. The nice thing about the PV move is you can do this completely live. You can have a very active file system or on an LV that contains data on this particular block device, and PV move will, in the background, shuffle the data off using something akin to a snapshot technology. And if this machine were to crash or unexpectedly reboot, or I suppose even expectedly reboot, there's enough checkpointing along the way that the kernel will know how to restart from the last checkpoint where the PV moves. So it's a really huge block device. You haven't, not all is lost.
I was going to say, this is a fantastic use case for this is if you need to move the underlying storage. For example, we are having a technology shift where we're moving away from using NetApps to do certain things, and we're switching to EMC storage. So all we do is present, the box obviously has the NetApp storage already presented to it. We present the EMC storage to it. We add the EMC storage to the volume group. Then we remove the NetApp, and we do the PV move, and it moves everything from NetApp to EMC live on the box. And then we remove the NetApp storage from the box. We unpresent it from the SAN. The box never went down.
Customer never had an interruption of service. We of course tell them we're doing this just in case.
Yeah,
We
always
because it's a significant operation, but
yeah, we always preface it with prepare for a window, but we don't expect to need one.
And we have done this before. All you got to do is make sure you've got at least enough storage at the destination PV so that it can shuffle all your data off, and it works. It really works quite well. Cautionary, and I'll mention this in a couple of slides. There's some degree of cluster support you can do in LVM, and we've had challenges with PV move in clusters. There's certain gotchas there. I'm not sure if that is fixed now. And under really heavy I/O, you've got to watch PV move. We did have problems where we foolishly, you should do PV moves one at a time. Don't try to do 20 different PV moves at once. Doesn't work so well.
Do them sequentially, not
We just wanted to get to the company outing that evening, and we were moving a little too fast. But the lesson learned. That was the first time. It's a known thing now. We don't do that again anymore. Lesson learned. And then once you PV move off of it, VG reduce. You give it the block device, the physical volume you want to remove it. And it's smart. It won't just remove it. If it's empty, then it removes it. Otherwise, it says, I can't remove this. It's still in use. You can force it. Don't do that unless you know what you're doing. I would never do that. Well, I don't know about never, but. And then here, this is one that I have frequently forgotten in the past. I've taught myself this habit over time. PV remove, dev SDD. You think here it disappears, you're not conscious of it anymore, but it still has that UUID on it. It still has the signature that says I'm available for LVM. If you were to, for instance, then go back to, we talked about like Anaconda and Kickstart. If you had a Kickstart where it sort of did programmatic things where it expected the box to be in a certain way, and it was trying to do certain operations with LVM, and you didn't have that label removed, and you tried to, for instance, PV create anything that wasn't dev SDA just to sort of prep it, and it already has a label, it's going to error out on that. So you could force PV create again, but it's a lot cleaner if you just PV remove the signature, and then it doesn't even look or smell or anything like an PV anymore. It's just a block device with all your data. Of course, that does not remove your data, so if you need it scrubbed for any compliancy, security, anything purposes, you've got to do that separately. But it does remove the signature. So other LVM notes. Dick, do you have a question?
No, keep going.
Okay.
Keep going. We could-
LVM2 is the current version of the LVM metadata and the tool set. It's been that way for, I think, since 2.6 was released, Linux 2.6, so it's well established now, LVM2. It addressed a lot of the problems with LVM1. There were certain scalability things where you had to kind of pick certain initial starting configurations to get to your sizing, and if you added a bunch of disk space, you could not be able to allocate all of it at some point. LVM2 is a lot more flexible, a lot more smooth working from the user standpoint. The metadata by default is stored in each PV that's in a volume group. You can specify 0, so a single PV won't store a particular copy of the metadata. Can't think of a good reason why I would want to do that, but there might be reasons out there. The default is 1, where it stores it at the start, or you can store 2 copies, the start and the near the end of the block device. LVM supports LV snapshots, so the idea being that you can take a block device, and if you have a little bit of extra storage, you can run an LVM command that says, I want to take a snapshot of this block device now, and it snaps it, and what happens is, at that point in time, any new updates that come in, the operating system will take the blocks of data that are being updated, move them off to this extra free space that you have to allocate to the snapshot, and then update the actual logical volume with the new data. And over time, as more things change, you sort of grow the amount of storage you're using on the snapshot. So you have to be conscious of how big that grows, because LVM will conveniently disable and, I think, remove the snapshot if it runs out of space. Because at that point, it's sort of an inconsistent view of the world. So you have to make sure you're monitoring that if you want to keep this backup over time. And there's a performance impact, because every time the data comes in, it's got to sort of do this shuffling where it keeps the old copy off to the side. But what that does let you do is, if you were going to do, say, a major update of your Linux distribution from RHEL 5.4 to 5.5, and you wanted to sort of take a snapshot of the system, in case you wanted to roll the whole thing back really easily, or you want to do maybe an upgrade of your Oracle database server, and you wanted the ability to roll back. Snapshots are a really quick, easy, cheap computational way of doing that. They're instantaneous, essentially, from the administrator standpoint. And once you're sure you don't need it, you can remove it just as quickly. And it just sort of deallocates that and stops the shuffling of the blocks. But you can take that snapshot, you can mount it like a file system, read-only, and work with it. Or even read-write if you do it a certain way. You can do it either way.
Good evening. The time is now 8:45, and the library will be closing in 15 minutes.
I will be done.
The library internet connections will shut down approximately 10 minutes before closing. So, if you are using one of the library's computers, please begin to save your work and complete any printing now. Also, if you need to apply for a library card, check out any materials, or call for a ride home, please do so at this time.
All right. So, we talked about PV move. A gotcha is you can't have 2 different volume groups on a system with the same name that have different PVs. So if you name them all the same, like my VG0 example, and then your system melts down, and you move it from one home system to another home system where you've also named it VG0, expect headaches. You could embed the host name, you could vary it up. There are ways around it, I think, but they're kind of ugly. It's been a while since I've had to do it. And if you happen to ever bump into HPUX's volume management, they're very similar commands. I don't know if it was based off of that per se, but I strongly suspect they looked at HPUX and said, this is kind of a good way of doing volume management, let's model that. Not perfectly exact, but if you ever happen to sit down after learning Linux at an HPUX box and you say, this looks familiar, that's why. Basic unit of allocation in LVM is an extent. In LVM2, it defaults to 4 megabytes. That's unless you override it when you create the volume group, that's the smallest unit of storage that you can sort of divide. So you could create a 4 meg LV, an 8 meg LV, but you couldn't do a 6 meg LV. That's like the smallest chunk.
You could, but it would take up 8 megs.
That's true. You could create 6, but it's going to use 8. Fair point. LVM uses device mapper under the hood. That's a kernel facility, and that's the thing that does the magic of saying, I'm going to present a block device that looks like it's contiguous, but under the hood, I'm going to map this group of sectors here, this group of sectors here, this group of sectors there. If you happen to be using the device mapper multipath configuration, if you happen to run a SAN where you have multipathing in, or some sort of a SCSI device where you've got 2 paths to your card, and Linux sees both those paths as well as the multipath device, make sure you check out the filter directive, because LVM may prefer not the multipath that would keep you up if one of the paths goes down, but instead one of the underlying paths. So it will pick, usually I think, the first one it finds. So check out lvm.conf and use filter to remove the underlying paths and just see the one that's your multipath. So you actually are protected against the failure, and that's something I think that typically gets missed. LVM can be used in clusters. You need an external daemon to coordinate the basically notifying metadata updates to other cluster members. There's a locking option to do that. Red Hat Cluster Suite supports that via CLVMD. I don't. Yep. See? Done. So, let's get the demonstration. So, LVM if you're on a rescue mission.